Aloha and welcome to our video on continental drift. In this video, we'll describe the hypothesis of continental drift, we'll look at some of the evidence in support of it, and we'll identify the main objection to Wegener's hypothesis of continental drift. So to begin, let's talk about what is continental drift. Alfred Wegener was a scientist, a geologist, and he looked at a map and realized that South America and Africa, if you looked at their coastline, they kind of fit together. Now, this was kind of an interesting phenomenon for him to look at because one of the things is it was a 90-degree angle on both of these, and that's not a very common shape in nature. And to find two of them that were separated by an ocean that looked like they at one point in time matched together, he hypothesized that several million years ago, all of the land masses might possibly have been joined together, and that over time these land masses were moving apart from each other. So if you look here in our picture of Pangaea, and we'll talk about that quite a bit, you can see the same area here where Africa and South America were joined together. And over time, what's happened is they've migrated away from each other. And that's what the idea of continental drift was, is that these continents weren't solid. They weren't one single piece. And that went against what most people thought. Most people thought the crust had to be one solid piece. And if it was, there's no way it could move. And Wegener proposed that rather than it being one, it was a series of different ones, and these continents were able to move apart from each other. Now, once proposed, people started looking for evidence. And what we found were a whole bunch of different things. We found that there were mountain types. You can see the mountain types here were the same of where these places were thought to be once together. You could find fossils of animals that only seemed to link up together, and fossils of plants that did the same thing. And by playing around with the continents and putting these evidences together, what we were able to do is put them together. That's how we got the shape for Pangaea down here. You can see all of this evidence, how it lines up, kind of shows us that at some point in time, these had to have been together. And this was the evidence, and like I said, there's a bunch of it here that shows it, but Wegener did have problems trying to convince everybody that this is what really happened. So why wasn't Wegener's idea accepted right away? Well, there were a couple things. It was a change in the way we thought of the crust. We thought the crust had to be one solid piece, and now we were saying that it was different. There was belief that the earth was static, that it was the way that it always will be, and it's the way that it always was. But this would mean that it was dynamic and that it was changing, and that was kind of a new thing for people to think of. But also, there's a significant lack of a mechanism. If we had these big pieces of the earth here moving around, well, what caused them to move? What was that force that was doing that? It couldn't be something as simple as wind or waves or something. So we lacked this mechanism, and because of that, a lot of scientists rejected Wegener's hypothesis, even in lieu of the evidence that showed that it was probably correct. Okay, so that's it for our video. In the lesson, they'll go into this in a lot more detail. Good luck on your quiz, and we'll see you in the next video.